have a look at this integral, okay? This is a perfect example. It was very, very well crafted. It's a perfect example of an integral which, because of its nature, can be approached in many different ways. I saw at least 6 different ways. 3 of them were about okay. 1 of them was the best, okay? So I'm going to show you, I won't rehearse all the way because it'll take me forever. But I will show you the important, like the basic pathways and where I awarded marks for each one because everyone went different ways. Okay, so probably the longest, so the least efficient, but the still okay method that I would count is to do this by parts. Okay, you can do this by parts. Probably the smartest way, if you want to divide this up, you think about what product is going to be most useful to you. You want to recognize tan squared. You can substitute that for sec squared minus 1, right? A couple of you did 1 minus sec squared. Basic stuff, right? If you always struggle with those, just come back to this guy. Because evidently, some of you do. They all come from here, right? And the signs, well, they'll muck you up, right? Usually, if you got the, for example, if instead of this, if you got this round the wrong way, okay, and that was the only error that you made, you probably got 2 out of 3, if you followed through anyway, okay? Now, if I go with that, you think about, okay, what am I going to divide up? You can choose this, right? That's easy to integrate, it's going to go tan. That's also easy to work with, okay? So you do this by parts. Where were the 3 marks? Number 1 was for the next line, okay? So that was your uv minus v du, which looked like this. Okay, if you did it by parts, here was 1 mark. The second mark was for going through and actually evaluating all of these. In other words, you had to actually get rid of all of your integrals, get it in terms of pi's on 6 and pi's on 3s and all that kind of thing. That was your second mark. Your third mark was for getting past that evaluation of the integral, right? And then to actually simplify. And there was a variety of ways to put it. Some of you stopped at, let's see, what was a nice place to stop at? 2 on root 3. Plus root 3 on 2 minus 2. A lot of you stopped there, and that was acceptable, I suppose. Would have been nicer to rationalize. You would have got something like this. Or maybe minus 12 all over 6. Okay? So let me just repeat that. 1 mark for your actual integration by parts. You don't get any mark just for doing a trig identity. That's not an extension 2 type of thing that I'm assessing. Okay? In this question. 1 mark here, another mark for the evaluation of all those integrals, and then your final mark for actually simplifying all that evaluation, okay? But, and this is why I skipped it, when you do it by part, you've got like 8 terms to evaluate, right? So that's what I mean by it's a very inefficient way. So by the time you got to question 4, you just ran out of time. Or you looked at question 3 and you thought, forget that. I got no time to mess with that because I've already spent so much time on this question, right? So doing it by parts, not the best way. What's a better way? I've lost track of my pieces of paper. Hold on. There it is. A better way was choosing a substitution up here. Okay? So instead of going to this line and using your Pythagorean identity to expand out, you might have gone straight from this line and said, well, okay, tan squared. That's sine squared on cos squared, right? So really what I've got is sine cubed on cos squared. Okay, yes? So at this point, a lot of you saw, okay, I can choose a substitution here that will work for me, namely cos x. That's almost certainly what you chose, okay? So once you do that, you get your du on dx, which is negative sine. If you're doing a substitution, of course, you have to change the boundaries, right? So there was the first mark. You see, it's a completely different pathway, right? So the first mark was for getting this part. X equals this. X equals this. You're going to get 2 values of u, right? So if you did it by substitution, you got your first mark for all of this, right? You got your second mark for, once you did your substitution, and this is the reason why it's better than doing it by parts, all you end up having to integrate is this. Look, no, that's wrong. Sorry. Right? So that was really, really easy. So you got no marks for just getting to that point after the substitution. You got the mark for doing the integral, right? Now, a lot of you did this by substitution, which was good. Better call than integration by parts. However, you got twisted in here, right? And you got very, very close, but you got confused with the fact that this is u to the minus 2, right? So your actual integral of this is this. Okay. So the number of variations I saw on people who either had a minus sign out the front, or had a minus sign in here, or had it flipped around and a minus sign, lots and lots of those kinds of errors, okay? So maybe at this point, if you saw you got to here, and then you mucked up the next step, maybe what you need to do is be more careful and take more time and say, look, that's this, right? And then make sure you get the primitive of u to the minus 2 correct. See these double negatives, right? They're a recipe for disaster when you're in a rush. So that's why those are the kinds of things that you've got to take more care with. Does that make sense? Okay. So after you got there, you integrated. That was the second mark. Number 1, number 2, and your third mark was for getting to the same point. Okay? All right. Now, we did it by parts. We did it by substitution. There was an even better way, an even faster way. And some of you will be like, oh, I can't believe I could have done it so quickly. Let's have a look at it this way. The reason why it's quicker is because it's one of those where you sort of have to see one of those trig identities. And if you don't see it, then you're left to go to one of these other methods, okay? So you started here, right? Actually, even if you did this line, okay? So you get to sec squared, right? But have a look at this. If you combine these two, have a look at those, right? That's sine on cos squared, right? Those two together, sine on cos squared. So really what that is sine on cos squared is sec tan, isn't it? Sec tan? There's the sine on cos and there's the 1 on cos. That's sine squared on cos. There it is, right? But sec tan, that's an integral you already, you know the primitive of this. That's a known result, right? And then of course you've got minus sine off on the end. Right? So if you saw this, and I think maybe one of you did, right? You get this very, very simple integral. Bam! Right? No substitution. Very, very simple result. Not like 50 million things you need to evaluate. And so that's what saves you time. You get to the same answer. Right? So that was the quickest way, right? But it took a lot of mental effort, I think, to see that and realize, okay, that's going to be a good way to go. Just as a point of interest, I think the reason, the thing that would separate people who recognize this and people who went other methods is that they know this is a useful result, right? So as in they know their primitives well, okay? So you can see how useful it is. Like, we hate memorizing things, right? But memorizing saves you time because it helps you recognize things, especially in the heat of the moment.